Hello guys, welcome to CS50 Problem Set 4 Recover Walkthrough Tutorial and Solutions. Today we're going to talk about the recover program, overview, pseudocodes, these two sections, and also the solution explanations. So in these recover programs, the user gonna key in /recover and cut.row. So in this cut.row, we notice there are different colors here because there are different images taking different number of blocks here. So what we're going to do here is to separate them out into multiple outputs, which is multiple images, up to 50, around 50 images of JPEGs file. So this is what happened behind the scenes. So we're going to F, as a user, we're going to F open the file. There are one input file and multiple to generate multiple output file, which is around 50 JPEGs. So before we go into the loop of f-reads, we can decline some parameters. So each block takes 512. So the block size is 512. So we have to count the image to generate the number here. So we decline this count image equals 0. So short form C_I. So always a good practice to decline the pointer equals to num. Asterisk output equals to num. So next, we decline the child file name array of 8. So we discuss this behind more detail. So after decline this, we're gonna f-reads block by block. So if we reach to the end of file, it will have a number which is less than 512. So normally we just returns 512 because each block is 512 bytes. Else, other than 512, it means end of file. So from here, we can check if, for example, the first 4 bytes is JPEG format. So we're gonna have a condition here, the first file. So we're gonna create a new name. So for example, this 000.jpg, f opens, writes, f writes, and add counter to the images. So this is only used for this first block here. So after that, we go to, for example, this 1, 2, 3. So this 1, 2, 3 blocks doesn't fulfill the first 4 byte of the JPEG formats. Therefore, it will just go to this statement, which is fwrite. Keep writing to the current file. So just write 1, 2, 3 here. So for example, this number 4, which is we have a new JPEG format here. So the 4 will go to this statement here, which will close the output here. We'll close the 00 here, and we create a new name which is 001 here. Then we repeat the previous step here, add the image count here. So we can see the 4 is under here. So there's a 5, 6, 7. So we just keep writing to the same file name, which is 0001 here, 5, 6, 7. After that, we're gonna f-close output and input. So as for the pseudocodes here, basically we just run program with the memory cards, open it, repeat loop by reading 512. So if the first 4 bytes is a JPEG for the first image, so we can sprint a new file name, fopen, fwrite, count the image. Else doesn't fulfill the new JPEG requirement, which is not the new beginning of the new JPEGs. So for example, this 000. So these blocks will keep writing in the 000. So else we go to the new JPEG file. So you go to 001. So it belongs to these statements. Then at the last, we just close it. So you can see here in the coding more detail. So this is a library. So this is the new data type. We define the unsigned 8 bits into the bytes. So each block is 512. So the main program here. So later on, we're going to divide these two sections here. So we're going to check for two command line, open the file and check for failure, decline the 4 parameters, which is this 4 here. Then the internal loop, the F4 loop, then the first 4 bytes, not fulfill the first 4 bytes, then yeah, for example 001. So this is the first portions. To check for the two command line arguments, we can use this statement, this code here. So argc not equal to 2 means here argc is this. If the user doesn't key in this, so you return 1 here. And also if the file doesn't, for example, we have to this portion here. So this portion divided into 2 portions. So we have to open the file here. F opens argv1. argv1, it means this argv1 here. So basically we just read this card here. So for here we put file in the example. So from our code we just put input just for clarifications. So we can use this either this code here or this code here. It means that if this is the pointer, if the address doesn't consist anything, so return 1. We just print and return 1. Okay, so this is the 4 parameter here. So this block 512, count image, num, and for this file name here, so you notice that the xprint here has this thing here. So this basically means 30, so 000. So this I means this is the I here. So the I is equals to the count image. For example, the image is 0, so it's 0, the 1. So how can we know what is the size here? So you notice that this is 1, 2, 3, 4, 5, 6, 7. So we have another num characters here. So this is 8. So this should be 8 here. So next we go to the internal loop. So the internal loop is we have a while loop to keep reading the file. You can notice that it's similar for this code here. So basically when we read 512, so just exchange this tree with block size equals to this block size. So you know that is always the feedback here. Is always feedback 512. If less than 512, it means end of the file here. So from here, you check for the first 4 blocks for the JPEG formats. So this is the one you can use. You can refer here. Sorry, yeah, just refer here. So we add another line here, another end statement. This is known as the Bitwise matrix, which I will put a link. I will have written a blog about this. So here, from there you can understand more. So from after that, we also will have some case that doesn't fulfill these 4 blocks. So for example, for here, normally for the first image, it will fulfill the first 4 blocks. So this is the image 0. So the image 0 will be here. So the S prints, F opens, writes, then F writes at the count image. So this is the 0 here. So for example, the 1 here, it doesn't fulfill the 4 blocks. The 1, 2, 3, the 1, 2, 3 will be here. So this one is number 5. So number 5 will go to here. So it detects the first 4 blocks, but the image count is more than 0. So we will close the previous file here. Then it will keep writing the same thing here again. Okay. So notice that the red color is for you to fill out. the green color is the correct code. Right, so you can see the 5 is here, so the 6, 7, 8. So 6, 7, 8 is here. So this is the internal loop here. So remember to F close your output and input. So now pause the video and try solving it before continues to the solution sections. Okay, welcome back. So we're gonna go to the solution sections here. Okay, this is the code that I wrote. So this is the tree library. So this is the new data types. So we define the unsigned 8 bits into the bytes, 512 into the block size. This is the main program here. So check for argc not equal to 2. So we have to print this, which is the usage recover image, return 1. Then we open the cut.row file, the inputs. So this argv1 is the cut row 1 into the read form. If the address doesn't contain anything, we just print could not open the file, return 1. So decline the 4 parameters. So the buffer 512, count image equals 0, asterisk outputs equal to num, child file name equal to 8. So this is the while loop for the f reads. So if it keep returns 512, means we can keep reading it, else is end of file. So we check for the first 4 bytes here. So for the first image, we're gonna create a new 000.image JPEGs. F open the files, write it, and add the counters. So for the subsequent 000.jpegs, so we're gonna doesn't fulfill the 4 bytes, keep writing to the same file, means it will keep writing fwrite right to the outputs, the same output 000.jpegs. So once we saw another repeated JPEGs image, so F close the previous file, create another new name, F opens and writes, F writes and add the image count until we go to the end of file here, which is not equal to the block size. So F close the output, F close the inputs. So you can see here is all okay for the check 50. This is how I solve the recover problems. So that's it. Thanks for watching and see you next time.